All right, so let's go over a couple more examples on how to find the domain dealing with different types of functions. So for 5, we have y is equal to the square root of x minus 3 minus square root of x plus 3. So again, we just want to make sure that we don't have anything inside the square root that's a negative number, because we can't take the square root of a negative number and, well, you can't take the square root of a negative number and it would still be a real number. We would have to get into the imaginary numbers. So what we're going to do is look for the values that make this negative and make this negative. So it's essentially just like solving for x minus 3 can't be less than 0. Or I mean, let's just actually do this string, talk about the domain. We need x minus 3 to be greater than or equal to 0. And then we need x plus 3 to also be greater than or equal to 0. That means that x has to be greater than 3 and x has to be greater than or equal to negative 3. So for both these to be satisfied, x would just have to be greater than 3, because if it's greater than 3, then it's greater than negative 3. And so on a number line, close circle on negative 3, or close circle on 3, arrow to the right, like that. You want to write this in interval notation. That would just be a bracket around 3, comma, infinity, and a parentheses around infinity. Let's put that 3 a little closer over here. If your teacher wants you to have it in interval notation. I like this notation better, but sometimes it's got get used to it. All right, so number 6. Okay, to the top, again, we just want to make sure that stays 0 or greater. And same thing with the bottom. Actually, the bottom just can't be 0. So we basically need two things, actually. So 2x minus 9 has to be greater than or equal to 0. But then also 2x minus 9 can't be equal to 0. So we're just going to include an extra number when we solve these. So then adding 9 and dividing by 2, we're going to get x is greater than or equal to 9 halves. Let's get this out of the way. And then adding 9 and dividing by 2, x can't be equal to 9 halves. So all this is saying is that x has to be greater than 9 halves, because we're not going to include 9 halves. So essentially, x has to be greater than 9 halves, or x has to be greater than 4.5. This will be our actual answer. So that would just be a number line, open circle at 9 halves, or 4.5 is a decimal, arrow to the right. Interval notation would go from 9 halves or 4.5, but the parentheses, since we don't include it, comma, infinity, the parentheses, and there we go. All right, one more, number 7. Okay, so the top doesn't matter because we can square any number and we can multiply any number by x, or any real number by x, and square any real number. The bottom, though, we're talking about the 4th root. So we're talking about a number that you multiply by itself 4 times, or raised to the 4th power. So then the thing is that anytime you raise anything to the 4th power, it's always going to be positive. So then that means that x plus 5 needs to be greater than 0. So it can't be 0, though, because if we were dividing by 0, then it's going to be undefined. So then our domain is simply just x has to be greater than -5. On number line, open circle on -5, arrow to the right. And then interval notation, parentheses around -5, comma infinity with the parentheses. And you don't actually have to write the x is an x epsilon like I do here. I just like writing it because it's cool, but you don't typically need to write it. Your instructor should know what the answer is or know what that refers to. All right, so there you go. I hope that helps.